And I want to look at the graphs of proportional relationships and how we can represent them as graphs in the coordinate plane. As an example, let's suppose that you can swim at a steady pace of 5 meters every 4 seconds. Well, since you're keeping a standard pace, the number of seconds and the number of meters are going to be in a ratio of 4 to 5. And so they're in a proportional relationship. So we have seconds to meters as 4 to 5. Well, I can actually represent this relationship as a graph in the coordinate plane. All we have to do is pick one of our axes, let's say our x-axis, to be time, so seconds. And then our y-axis will be distance, or meters. And so to represent our proportional relationship as a graph, we just plot the pair of corresponding times and distances in the coordinate plane. So for instance, if this is 4 seconds and 5 meters, then we would have this point, since our ratio says 4 seconds to 5 meters. If we know that if we swam for 8 seconds, that would be 10 meters. So we also have the point 810. And we can keep going. And what it's going to happen is that all of the points are going to be on a line that passes through the origin. So here would be 12 and 15. 20 meters would mean 12 seconds, etc. But all of the points are going to be on this line that passes through the origin. And we can also see how the 4 to 5 ratio of times to distances is reflected in the graph. Moving along this graph, if we move 4 units to the right, we move up 5 units. Over 4, up 5. Over 4, up 5, etc. So the unit rate, 5 over 4 meters for 1 second, corresponds to the point 1 second and 5 over 4 on our graphs. That does actually correspond to a point. But also, if you move along the graph, as you move to the right 1 unit, you move up 5 over 4, just like we should expect from our ratio.